everyone for inviting me for this great opportunity. I'm happy to be here and give this lecture. As I said, I wish I was in a better situation to prepare the things, and right now I tried my best. I hope you would enjoy the lecture. I assume that you all are students, and of course, my lectures usually are interactive, and in the online sessions, it's a little bit difficult and tricky, but please interrupt me if you have any question or comments, because usually in an in-person class, we discuss the things through the slides, but I suppose it would be challenging through the online slides. So in this presentation, I tried to explore the sensing technologies for the built environment with a focus on geomatics. Um, I tried actually uh, to simplify the content as much as possible, as I wanted to explore the main component in this technology and how they evolved and how they impact the human life. So I hope it can, the main point can be delivered, but please, as I said, interrupt me if you have any comment or question. So in this presentation, first I introduce the sensors. Of course, it's about sensor technologies. So we start with sensors and how it uh, how it works and what type of sensors do exist there, and different relevant topics about the sensors, and then we explore some applications while we discuss the relevant aspects for the trends of evolving the sensor technologies. And we also mention about the future directions and how it goes, where it goes in the future. So the sensor technology. Uh, but first about sensor. Sensor is a device. It's something that measure a quantity. So there are different types of sensors available in different forms, different shapes, different size, and all I mean, the purpose of using these devices is to measure something. To always we have some physical entity in the real world, and we try to quantify it, and the device actually uh, generates some output as an electrical signal or optical signal. So this quantity can be sound, can be heat, can be pressure, or light, or motion, distance, or humidity, and any entity that we may imagine to measure in the real world. It would be possible to use such devices to quantify it and quantitatively measure the value for it. So it's all about measurement and data collection. So for any subject that we specified here, we get some data. Through time, actually, there are progress. Actually, the devices, the sensors, actually, miniaturization happened, and it means that the devices are getting smaller and smaller with the better performance and better capacity. Another trend, so I'm talking about the key trends in sensor technology. So another trend that we had in through time historically is digitalization. So now all the sensors actually are digitalized, provide some digits, some quantitative measures. And another key trend is the integration. So we have for many applications, we have a couple of devices, a couple of sensors integrated together, fused together for a certain application. So these are three key trends in sensor technologies. But let's see how it works. So there are different types of sensors. For example, we have light sensors. It's obvious, it measures the degree of the intensity of light. There are a group of proximity sensors that it's actually contactless sensors without a physical contacts detect an object, the presence of object or movement of object or distance, whatever. So it can, for example, be ultrasonic sensors, optical sensors. It may use infrared or LiDAR or radar and many more. We have temperature sensors, we have humidity, chemical sensors, many more. So traditionally, we saw the weather, the sensors in weather station to collect the weather data. We have them in the total station, the surveying cameras. We have even in speed cameras using this technology, radar technology, for example, LiDAR technology to measure the speed. So in different ways, they affect our life. Even in our smartphone, it has a couple of sensors for different type of sensors. And every day, uh, many more are added to these smart devices. In the health, there are many health applications to measure different quantities in our body regarding the health management. So we have many type of sensors like this. Or I'm sure you heard about the autonomous vehicle, the self-driving cars. Actually, it's an example of the integration of sensors. So in the self-driving car, there are many type of sensor like radar, LiDAR, even cameras. So these kind of sensors are integrated together to make it possible to make this car self-driving as a self-driving car. So in geomatics, actually, we know all that remote sensing is evolved a lot from sensing technology. We have actually a lot of satellites with different sensors, with different generate different type of images with different spatial resolution, temporal resolution, and with the different technologies like active technology or passive technology. For example, here you can see a LiDAR type of images. And the base of this remote sensing technology is a kind of proximity or contactless sensors that use electromagnetic reflectance as in different ranges of this reflectance to measure the quantities in different applications. So in geomatics, these sensors can be on satellites traditionally, but they can also be used in the built environment in cities. For example, we have radar or LiDAR sensors to detect objects in the cities, in the streets. For example, we have some applications there. So we have different platforms that we can use these sensors, but all actually can provide some geospatial data that can be used for geometric applications. They can also be attached to drones. So it actually shows the evolving technology in the field of geomatic that use the sensor technology coupling with the other technologies to provide some applications. So advances in sensor technology actually improve our capacity for data collection. That's obvious. So new sensors and new capacities actually provide the possibility to collect more data, uh, precise data, and more accurate data. But what else? There are some concepts that in the last decade or 2 decades actually have been progressed, like citizen science or crowdsourcing, that actually use human, all of us, as a source of information. So we can contribute to, for example, use our phone or any devices that we can use here to provide some data. So it is kind of advances in sensor technologies because we help to collect such data. The um, aim behind these advances is to improve the data collection. And this is kind of influential concept that has been used in the last decade, especially to given a lot of, a smartphone and such devices capable for collecting many data. So we can use to provide, to improve data quality capacity. But the challenges that we have here, especially specifically for geomatics or geospatial science, is that given these diverse type of sensors and a lot of data resources available, we are dealing with big data, because it's not like only the improvement in the precision or spatial resolution, but it's also improvement in the temporally. So we have like more frequent data, and it means that the size of data is getting bigger and bigger. So another challenge is communication. We have like different sensors, so the data should be delivered, or the sensor should be communicated for many recent applications. And another one is data processing. We need to process this data. So I just put these three key terms here because I want to, I believe that these three key terms are important to understand what is behind this technology and how these technologies are evolving in the field of geomatics. So let's see what I mean. So we know that, yeah, especially in the last 2 decades, we have a good capacity of high performance computing and cloud computing. A lot of good resources are available for any kind of computations. So that is for dealing with, processing big data. But there is one influential concept that is important a lot here in using sensors, and especially for the field of geomatics. That is the Internet of Things. This concept actually make it possible to simply address the communication challenge. So it's a simple concept. Each device can be connected to the internet, and then when they are connected, they can communicate to each other and make a kind of network. So it really makes the things easier and provides a lot of potentials and capacity for a lot of applications. And another influential thing that has been evolved, especially in the last decade, is artificial intelligence. So by improving our capacity in computation, we have the algorithm for machine learning and deep learning improved a lot, hugely improved, and they offer a lot of application to process the data, to understand the algorithms in the data. So we will discuss a little bit on either of these terms. So about the Internet of Things, it's, as I mentioned, it's easy. Each device is connected to the web, and then they can be communicating to each other. They can exchange data and make a kind of network, or there is a term like sensor web, for example. We just put the sensors and devices on the network, so make it possible to communicate with each other and exchange the data. And especially for the one of the trends that I mentioned, for many applications, we need the integration and fusion of different sensors together. So this IoT technology actually plays a very important role to make it possible here in this case. And one of the very important capacity that we have by bringing IoT technology here is to real-time or near real-time monitoring of the measures that we have here. So we can continuously monitor an entity, a physical entity that we are interested in. And of course, this capacity provides make it much easier and more efficient to maintain the devices and the whole technology. So this artificial intelligence actually is a kind of learning algorithms that can be used effectively to gain insights from the data and understand the patterns from the data and classify or predict the data. It plays very important role in the field, uh, in many disciplines, including geomatics and using sensor technology. And by having this artificial intelligence integrated, we simply convert the sensors into a smart sensors. It's very important, actually, an important trend that we have, because these smart sensors actually has the capacity to learn the things and think, and also make the results that the sensor generate more efficient. So it's not like a simple device that collects some data. It has the capacity to learn, for example, to understand the best way to collect the data, how to reduce the noises, for example, or what exactly should be collected to make everything more as efficient as possible, or detect the failures if there is any failing in the data. So it's changing a lot the capacity of these sensors in many applications. So it can be coupled with kind of processing algorithm, and therefore, instead of raw data, it can provide some interpreted information. So it's very different here when we have the smart sensors in many applications. And of course, we would say that the behavior is smart, so they can be smart in many aspects, as we mentioned here. So in geomatics, actually, we usually have some the concern is, like, for example, we have a good spatial coverage, like dense spatial network. It's one aspect when we want to, for some application, that we want to use the advantage of sensors, for example, to monitor some an entity. So the spatial coverage is one important aspect. And then for many applications, the temporal coverage, if it can be a real-time coverage with high temporal resolution, is another aspect that is possible now with the advances that we have in the smart sensor technology. And it can be integrated easily with the other data streams. So it's like a kind of fusion in the different resources of data. And that's why it can easily be used for scientific data processing. So it can automatically generate some outputs that have the values, would have scientific values, and can be directly used, for example, by for example, by managers for making decisions, or automating the decision making, and so on. We have like a lot of advances in visualization technology, given the advances in the sensors in geomatics. We have a lot of workflows and procedures automated, and we have the algorithms and workflows for good interpretation of the collected data by sensors. So we can simply say that we would be able to develop a smart system. So in a smart system, as I said, we have, I believe, three components are important: the sensor technologies, the communication technology, and the data processing technology, which is, for example, machine or deep learning algorithm. So by having these three, we can simply provide a lot of application and develop a lot of smart systems in any environment, including built environment, like the smart cities that will go through it. Another important thing that we should not forget about the geomatic-based smart system is the location-based services or positioning system. So that is another component that is very important, as it's part of the many devices that we use here. So these data are important. Even indoor positioning are developed now, and we can simply use the same as what we have as GPS outdoor. We can have such technology to use the location-based services indoors. So the advances actually are happening in either of these technologies together. So we have some studies that only work on at enhancing the sensor technology or an Internet of Things or developing machine learning algorithm. But there are also some trends that try to integrate these key technologies together for some applications or for some developing some system that generally we can say it's a smart system. So if you want to um, just review the technologies, quick review for in Geomatic, we have like a space for like satellite images, drones, and different land-based sensors available here. And there are some other technology, as I said, we have navigation sensors, we have radio frequency sensors, and the other sensors that measure the quantities can be either passive or active. So one of the most influential technologies that have been, changed a lot in recent years, many applications, is the Lidar technologies. So um, so these active geomatic sensors is radio detection or radar, radio detection and ranging that use a long wavelengths microwave reflectance to record the amount of energy that has been emitted from the sensor back from the train, from the object that we use. And LiDAR technology is kind of the same technology, but it uses short wavelength laser light. So it's more efficient, it's much more efficient in terms of precision and the capacity to use to measure the things and objects in space and time. And sonar, actually, it's obvious that it uses sound signal. So all of these technologies are active geomatic sensors. As I said, LiDAR is one of the most influential technologies in recent years. So there are a lot of development there. So uh, it has been used in many direction and many applications. As I mentioned, even in the self-driving cars, in the street, in the built environment, we have the use of LiDAR. Even for speed cameras, we have now the sensors based on LiDAR technology. So it can actually be used here. Let me just show some application. So first of all, laser generates some optical pulse, the way that it works. And pulse is reflected off an object and returns to the system receiver. So that's the optical pulse is generated, and the reflectance of that pulse is received by the system. And then there are some sensors that try to measure that signals that have been received, and the time measurement. So we have like different pulse, and the time between each pulse is also measured. So the measurement can be interpreted as the distance. One of the important information that we can have from this kind of LiDAR technology. So there are multiple returns can be measured for each pulse. So the intensity of the data is so high. That's why it provides a lot of capacity for this. You can see an traditional example of LiDAR for mapping, 3D mapping of the object. as you see in these pictures. But another applications is to detect vehicles in the built environment, in the roads, for example, uh, that we can detect pedestrians on the street and vehicles. So it can also be used in the cars to detect either pedestrian and vehicles. So to have actually to make it possible, it's not only the sensor technology, but they are coupled with the data processing technologies, and also the probably the Internet of Things or the other communication-based technologies to make it possible to have such applications. So we have such capacity, such algorithms based on the LiDAR technology right now that follow some workflows how to do that. It's like that you know, the structure of data is not that difficult, that complicated. It's like a lot of measurements that you first require to filter out, for example, the background. If the object is here, like this pedestrian, you need to filter out other measurements that are not relevant, and we call it background. And that's why then you need to select the region of interest that you need to focus. And these region of interest are going to some machine learning algorithm for classing to understand whether, for example, is in this case it's pedestrian or not, or whether it's vehicle or not. And that if that is classified accuracy, then it can be used to track that pedestrian, because the trained algorithm can follow, can track the object there. So it provides a very good way of providing the data and monitoring the object that we are interested in. So there are some different algorithms for clustering. And this, in this case, for example, I just wanted to show how in a study that they provided how the data looks like when the object, the pedestrian, are getting away from the LiDAR sensor. Still, when it's get away like 26 meters, in this case, it was possible to detect the object. So it shows like the capacity of the algorithm. And the algorithm behind detecting this thing is based on density-based spatial clustering application. That is not actually very complicated concept. And we can use also train like artificial backpropagation or artificial neural network based on the measures that we have from LiDAR, like two-dimensional distance, direction, and total number of points to cluster, to classify pedestrian and discriminate pedestrian flow from vehicles. One of the recent recent trend that we have to integrate all of these things is the concept of smart cities, that I think it's relevant to the use of this geomatic technology in the built environment. So in smart cities, first of all, we use these sensors technology, Internet of Things, to communicate between these technologies and process the data and make everything smart. So as I discussed earlier about the smart systems. So there are some key aspects like connectivity, for example, one of the main key aspects in developing a smart city. A smart mobilities, for example, is one important aspect. So mobility in cities become a smart mobility when we couple this sensors technology with the positioning, you know, a couple of um, sensor technology like positioning technologies and some measurements that we have for mobility. So it make, if we have like a perfect smart mobility, it makes the accidents and facility uh, accidents in the road zero, or carbon footprint zero, and the level of stress in the cities zero. So that is triple zeros that we have when we have a perfect smart mobility in smart cities. The positioning, as I mentioned, one of the key aspects that is very important to develop such a smart cities. So the exact location, outdoor and indoor, uh, should be measured. There are technologies for indoor positioning system that have been developed in recent years, and they showed very successful. So in the locations that we don't have access to GPS satellite positioning systems, there are ways to couple, to integrate the uh, things and some solutions like wireless solutions, Bluetooth, and using other sensors on the smartphone, for example, to generate um, the positioning indoor, or navigating indoor. Uh, Self-driving cars, as I mentioned, use many of such sensors together, and it's an example of again, putting these three key things together: integrating the sensors, communicating with them, and processing the data. So it's like artificial intelligence play an important role to make it possible. So you see, there are many sensors, and some sensors use lidar technologies. Some of them are based on just cameras and vision that we have. So you can see that integration of all of these input can make it possible to train a deep learning algorithm to make it possible to, you know, uh, make the self-driving car available. So for example, here you can see how we can avoid the collision in a street. So it's exactly the same as the same procedure as we had for detecting pedestrian or vehicles. Here, one clustering algorithm is integrated here that detect the vehicles using a LiDAR technology. And then when you detect the object, it's possible also to measure the distance, and that's enough to avoid any collision. So there are many uh, aspects or horizons for smart cities. Some of them, like Internet of Things, we still need to develop, but it can make many applications like business, agriculture, environment, governance, and so on smart. Uh, so we have here like the main, um, as we discussed, smart mobility and uh, smart people. It's possible. It's the main component that we would implement in smart cities. Um, so the reason that it's possible to have like a smart city is that because today uh, 3.6 billion people live in cities, and by 2050, 75% of the world population will live in cities. And right now, actually, more than 80 billion connected objects already there, and it's growing exponentially. So we already have the things to make it possible to make all the aspects like a smart mobilities and all the other aspects that we discussed possible. So implementation is available and feasible now, right now. And for example, just 20 years ago, we didn't have any term like Internet of Things, but in 2015, we have 6 billion of devices worldwide. In 2013, 2030, we have over 100 billion of devices that are connected. So it's growing really uh, exponentially. Um, we have other application. I tried because of the time. I tried to just pass it quickly, but it just shows some capacity of like technologies like Lidar for example, here for trafficking system, how the connected infrastructure sensing can provide high resolution traffic information in the smart cities. So it's based on, the LiDAR technology, as I mentioned, is so influential, and the connected vehicles. So it would be possible to, uh, you know, uh, to provide this trafficking information given different objects, as you see, even if it's complicated, like if different type of vehicles, bicycles and pedestrians are there, by when they are connected to each other, the vehicles are connected, and there are some LiDAR sensors to detecting the objects. It would be then possible to just make it develop a kind of a smart system for trafficking and make it efficient. This LiDAR technology can even detect objects in different lanes in the streets. And usually for this, there is like a kind of a minimum area rectangular circulation. That is the way to identify the objects like vehicle, but I don't want to discuss the details behind it. I just wanted to show that there are uh, implemented and successful procedure to use this capability for such applications, that we use raw lidar data for detecting object, clustering object, and then tracking the object. In the other application, for example, this is a study that I was involved. We use some sensors on the bodies to like accelerometer and GPS data to identify the physical activity by humans. The output of such data could be such maps like the density of people or running in the city or biking in the city. Uh, for the future trend, actually, it's the last slide. I believe that we would have um, this a smart key term even more influenced on our life. You know, we have robotic technology that use this a smart system, and I believe in a near future we would have more uh, a smart way of controlling this data collection. Just imagine that such drones, now we may have a sensors. It can be coupled with some smart algorithm, and then can be controlled by human. But just imagine, this is a kind of flying robot, and it is smart enough to go by its own, collect some data, make decision where to go, how to collect the data, and even can communicate with the other objects or humans. Human can call a system and can response this drone, the smart drone can respond and go there and collect some data. It's like a kind of flying robot that plays as like a police in accidents, for example. So in future, I think there would not be such surprise because the technology is there, and we just need to integrate these things to provide a lot of capacity for nicer applications. And we know that there are a lot of investment for developing robots in many disciplines, many applications. And uh, this would not be happening if we don't have like such sensor technologies to those three key terms that I mentioned, like the sensor technology, communication technology, and the artificial intelligence. Integrating of these three main components would make it possible to make the things as smart as possible. Thank you very much for your attention. Please, if you have any question, I would be happy to address them.
Thank you very much, Babak, and also thank you for putting the use of sensors in the context of the applications and showing the wider context, also mentioning governance. Who would like to ask the first question? If not, I will ask the committee members. Bastiaan, would you like to ask the first question?
Yeah, sure. Thank you very much, Babak. Interesting overview of the entire field. I do have a question on this course. We have this very first course for our first years, Sensing Technologies. That's the name of the course. Is this lecture a typical introductory to this course, implying that you are going to address in the rest of the course all different kinds of sensor technologies, but also Internet of Things, concept of deep learning, artificial intelligence, and maybe even touch upon the ethical part of sensor technologies?
Yeah, if I believe it's probably if it's just within a single course, all of these concepts are too much for a single course, but it's like a kind of master program that should address either of these components separately, because, for example, for artificial intelligence, we may need several courses to be able to really use, for example, those algorithms for such application that we had for clustering pedestrian and vehicles and so on. It's not possible to have a single course and address all of them, of course. But I think in your program, probably, at least for some advanced module, probably some students are interested to go toward that direction. And that would make sense to define such, a series of course that eventually covers all of these aspects. Because for such applications, we require the knowledge for either of these components that we just reviewed in this lecture.
Did you also have a look in the program we have at this moment? And do you see any linkages between the sensing technology course and the other courses that we offer?
Yeah. Actually, the Geomatic program for the built environment, I think it provides the the base for. I believe many students there would be interested in doing research on some of these applications, for example, that we had here, or relevant applications using sensor technologies. But in the other geomatic fields, also, I think it's in environment or other type of application. Also, it would work, and we require such setting together to. So I would say it's not like specifically for any certain background like built environment. It can be more generalized to be used in other disciplines as well.
Okay.
Okay, Bastiaan, thanks. Who would like to ask the next question? Michaela, perhaps?
Sure, thanks, Peter. Thank you, Babak, for the presentation. Very clear indeed, quite engaging. I have a question that, well, you were mentioning now the built environment, and yes, definitely that's one of the or the key focus in our case. And even more specifically within the built environment, there is within the faculty a lot of emphasis on the design part of it. Not only, but there is quite some emphasis on that. If you were to link the content that you're presenting now on applications that are design oriented, can you point out some possible fields there, some possible links, both in the teaching part, but also really in research?
Yeah, I think I think if definitely it's possible, because if you remember, I mentioned like visualization is one of the parts, and usually designers like architectures, the visualization plays an important role when you want to design and look at the perspectives and all the, you know, objects related together. So these technologies, I think, first of all, from that, you know, geometric part, or the part that we just put the objects together, it's obvious that we can use this technology, geomatic technology, to develop. But in case if we want, for example, to, I don't know if this covers like designing a smart cities. For example, here in Iran, we were just talking, accidentally, we were talking about developing a smart tourist village in north part of Iran. So that is like something that wants to be started from scratch. And if we want to, you know, make it as smart as we defined here, like using the sensor technologies and, you know, make everything connected to each other, I can imagine that, you know, it would be an important component when, I mean, one of the application, for example, here is to locationing the sensors to cover like the ranges. And it's important for the designers when they want to figure out the objects in that village or the city or the region that they want to put things together. So I would say not only the visualization plays a role, but the processing that we have here, for example, to calculate, for the example that I mentioned, for calculate the percentage of coverage for the sensors that we put here, or any other kind of processing algorithms would be helpful to make the design efficient.
Am I understanding you correctly that so you're thinking not only of using the technology to collect data and understand the context, and now eventually then a smart city works at the moment and can be further improved, but you're saying it could also be integrated really into new items, new design, new buildings, and then there is a body of knowledge that would actually can you, for example, give an example? I find this second direction, yeah, quite interesting. Can you elaborate a bit more?
Yeah, for example, we have like now we have a lot of smart buildings, right? In the smart buildings, you know, people can control many things by their smartphones, and you know, it is like an integration of many sensors there that make it possible, you know, for people to, you know, control the things depending on the what the purpose that the building is designed for. I believe it could be I mean, this technology and this possibility can be used to make it as efficient as possible.
No, thanks. Well, there will be much more to discuss about, but thanks to keep it here. Thank you.
Thanks, Michaela. Uta, would you like to ask a question?
Yes, sorry, I was a bit late due to some difficulties here to join into your presentation, so I didn't get all the parts there, and so maybe what for me was more interested were the basic things. I'm not from the field, I'm not from GIS, but from architecture and heritage, and so I was rather interested that you gave the explanations of the things, and I think Bastian already asked also the question of this, if this would be one lecture, and I think you answered already it would be rather different lectures, which already where you try to cover different aspects of bachelor and master knowledge or basic knowledge, but maybe to follow on what Michaela was asking related to research, so what could be possible fields. I mean, how do you see, I don't know, the architecture field or the architecture profession and the architecture studies, because this course is, I mean, related to an architecture faculty, I don't know, developing or maybe merging, or how much more digitization will be needed. And now GIS is maybe more linked to urban planning, and how familiar are you with that field? So you worked in many different, I think, faculties already. What would be your vision or for that? How to further develop maybe also programs?
Yeah, I think in general, I believe that in many disciplines, these technologies play influential roles. So it's not like limited to a certain field. And we can see many applications right now that people, researchers try to use like either of these technologies or the integration of them together to address some grand challenges in that field. You mentioned spatial planning. I think that is one of the perfect areas that we can use the best out of this integration of these things together. You know, there are some aspects that we can use. For example, even in that architecture that was in the previous question, sometimes we may use this technology, this capacity for measure the things, like we use the Lidar technology to understand the details and the components. It's like for mapping kind of application. But sometimes we want to like integrate this capacity together to build kind of a smart system. I'm I'm in favor of these smart systems because I believe that future is going toward making everything smart in many disciplines. So depending on whether we want to just get use part of this technology for a certain procedure or routine in certain application, I believe it would be possible in many disciplines. And of course, there would be like a reach of content that we can define in the teaching program, for example, or research program, relevant to either of these things that we mentioned here.
Okay, Babak, in my Zoom, your video is gone. It's not a problem as long as we can hear you.
Oh, okay, sorry.
Yeah, no problem. Yeah, and by the way, I like your background with I think the R code, but the statistics. You did not mention it in your lecture, sensor data and statistics.
Sorry, can you repeat again?
Yeah, I made a comment about your background, about your image background, which is about R, to do statistical computations.
Yep, exactly.
You did not mention it in your lecture?
Yeah, actually, this is the background loading the package, one of the packages that I developed, and it becomes popular right now. Many people are using it. So I just put it there because just before this lecture, I was teaching in a course to Portugal remotely, and that's about modeling. That's why I thought that it would make sense to put this background there.
Okay, thanks. Art, you raise your hand, and then we go to Edward. You're muted. Art, you're muted.
I'm sorry. Quite a few questions I had already have been asked, but there's one still which you mentioned in passing, but I think might be interesting. You indicated how data, big data, smart data can help us develop, manage, but also govern our cities. And when you go to governing, you get governance, and then ethics get important, and even abuse can be a part. So in your teaching, how would you help our students, on the one hand, get very enthusiastic about the possibilities and the new ways of thinking and working big data open for them, and the sensing technology opens for them, whilst at the same time, I hardly dare use the word sensibilizing anymore. It has a rather curious meaning in Holland at the moment, but how would you sensibilize them for the possible other sides of these technologies?
So to get the students motivated, actually, I think first of all, it's very important to understand their motivation to get that course. It's very, because I always use this opportunity to, you know, explain the things as if I'm going to make them motivated and provide a very efficient explanation. First, I think it's very important to understand why they are motivated to get that course and that field of study. But relevant to governance and the keywords that you mentioned, in fact, the trend is significantly going there. You know, it's we have like grand challenges right now in many situation that we need solution there. And one of the areas that provide the solution is using this smart system, because this smart system simply, first of all, enhance the communication and get the best out of the available data there, and then try to uh, you know make the, for example, decision making as accurate as possible based on the state of the art technology. So given that the aim of this technology is to provide some tools that would make it either easier or more efficient, like governing and the tasks that we need there, administrative things. Uh, I think, and then on the other hand, we can show that how these technologies can address the grand challenges there we have. So I think elaborating on the possibilities would provide enough motivation for the people who are interested in addressing.
But would you also go into, because what I aimed at the other side was also the possibilities for abuse. Sensing, knowing, tracking, steering can all be used by all kinds of institutions, governments, companies to influence us in any possible way. A great friend of mine is running our national.
Yeah.
He just gave me a book. We all say, I have nothing to hide. Anybody can know everything they want from me. That's what many people say. It's his job to tell us.
Yeah, I
should care. You do want to know what people know about you, and you do want to check on it. How
yeah, I understand your point.
There's two sides of.
Yeah, I understand your point. Personally, I believe that first of all, I have no problem myself that people know where I am, and my information is not like that private. But in general, I believe that it's the advantages are much more than such disadvantages. So if we want to consider a kind of trade-off, we would definitely need to go toward that direction. But I fully understand that downsides of.
Isn't that a bit of the easy way out? We make it in a trade-off, and we say, well, the advantages are bigger than the disadvantages. Let's keep going.
Yeah, but one thing.
Automotive for a long time.
Yeah, but I believe that there is also one possibility. I believe that these smart systems are evolving in a way that handling such abuse also would be possible eventually. I mean, we can find solutions to make it as minimum as possible. That I see that in these technologies, we have that capacity to think about minimizing those concerns.
Okay. Babak, I'm not sure if you made art comfortable. It's still scary, the smart sensors and the drones and the robots taking decisions. So it has to be indeed regulated very well, I think, and society have to decide. Art, if you don't mind, we move on to Edward.
No, let's move on.
The next question, Edward.
Yeah, I will send Art the re-exam of the course in positioning and location awareness, where questions 4 and 5 were related to that kind of issues that you would like to know where everyone is located, but maybe not all the time. Babak, really thank you for your lecture, and difficult to, or not difficult, to think about another question, but you stated that sensing technologies is about sensing the real world, the physical entities, about smart cities, smart buildings, and in my opinion, there is one part which is still not that discovered, and I call it the terra incognita, and it is just the indoor environment, because you can sense everything from everywhere, but in most cases, our own indoor environment is still only known to people living there. And that is very fine, but you also do have semi-public buildings, stations, airports, which would also like to have a proper 3D indoor model. What kind of issues do you think which are there to add that kind of unknown part of the world to what is already there, sensed, and how to do that?
If I understood your question, because the quality was not good. Do you mean, so I think you mean about the limitation in the indoor technologies, right?
Yeah.
The sensing, right?
Yeah.
Yeah, I agree with you that the potentials that we mentioned here, many of them actually are developed for outdoor applications, and recently actually they are evolving toward the indoor capacity, and it's much limited compared to the outdoor capacities. But we have like one of the important limitation we had that recently there are a lot of solutions provided for positioning that I believe it's not that big challenge anymore. But we would not have those. Of course, it's obvious that those applications that we use the drones or this kind of things that provide a lot of good information for us outdoor, of course they are not available, but probably in indoor environment make it more efficient to collect some some data based on fixed sensors. So I believe although it received less attention compared to the outdoor, but I believe there is good potentials there to enhance many things. As I mentioned, there is good potential for based on the fixed sensor type of technology. That there is another thing that I believe it would be the future trend, and we see some examples, some research studies, like for example in hospitals, the robotics, for example, in some hospitals just provide some services. It's application, but it's based on the capacity that have been provided indoor and make it possible. So that kind of applications also are, I think, push us toward reducing such limitations you mentioned.
Okay, thank you.
Okay, Edward. Onno, do you have a question for Babak?
Yeah, if there's still time. I actually do have two questions, but perhaps or hopefully two short ones. My first question is, and perhaps I've not listened carefully enough to your presentations and listened not enough between the lines, but I would like to ask you, what is your most urgent scientific question you want to resolve during the coming 5 or 10 years? Or in other words, what will make you famous in the coming years? And my other question would be, how would your colleagues, including your PhD students, describe you as a person?
Yeah, that's a good question. If I get this position, I think in the last couple of years I have been so active in developing the smart systems, and this smart system is working based on integrating the key technologies that I address in this lecture. So what I would like to address in the next 5 or 10 years would be like to address the grand challenges, for example, the human footprint that we have, like, or the human footprint that we have, its influence for climate change, for example, the carbon emission and so on. I believe we can, if we can use this technology to you know, develop such smart cities and make it as efficient as possible to reduce such human footprints, for example, and address such grand challenges that humans are dealing with. I think in general, I mean, my main goal would be characterized like this, but uh, uh, I mean, in terms of the topics that I'm interested, I would be interested in basically in that part of related to artificial intelligence and deep learning and processing the data, and then using that capacity to use like sensor technologies and other things as input, as like the tools that can be used for, you know, addressing such grand challenges. So I would say I will spend some time for enhancing, for example, the algorithms in deep learning or artificial intelligence, do some studies to offer some applications of using such technologies, and also try to, you know, set up some bigger teams that involves researchers in other relevant disciplines and go toward like developing such smart systems and addressing such big grand challenges and research questions I mentioned initially.
Okay, thank you. And my other, perhaps more personal question.
How do students describe you, do you think?
I think always the students. I mean, I was known to students as a person who are expert in the field of geomatics and you know, a spatial temporal modeler, and you know, a kind of methodological guy who are also interested in the applied areas. So I don't know exactly what you mean by this question, but if you want to understand the exact direction that I want to go and describe myself as, I mean, the label of those key technologies, I would say I'm mainly a geospatial expert and modeler, and you know, person.
Okay, but my question was more about your motivational and leadership style.
Ah, okay. Yeah, I think in general, when I'm doing in the, I mean, in this job, it's I always wanted to become a leader in the area that I'm working. So far I try to publish and work exactly on the paper that would be that influential, and then. Given that I have been always interested in teaching and also research, I think I would be known as a good researcher and teacher, and the students will remember me by the quality of the teaching and the content that I provided to them.
Okay, thank you.
Thanks, Babak. Sounds still diplomatic kind of answer. Natalie, do you have a question? Open the floor to everybody.
Yes, I have, but these are more the selection committee
Okay,
questions.
then we do
Not
that
with the students.
later. So anyone else? Then, okay, I will have a small question. I liked your three-part solution after the sensor. So we have the sensor, the big data, the communication, and the processing. And for the sensor big data, you mentioned cloud computing. And that is a bit easy. Just add more hardware and say, okay, hopefully that will do the job. Could you give a bit more ideas how to handle big data? A bit more detail?
Yeah, actually, I think that is the easiest part in the technologies that have been evolved recently, because There are a lot of capacities have been developed in the last 2 decades, I believe. Now, specifically for geospatial data, there are some solutions to, handle such, multidimensional data, like data cubes, for example, one of the structures that have been introduced recently. So there are some solutions to make the computation of big data regarding the structure of the data and the model. So we should use those technology. And the other thing is related to the computational technology that is required here, like parallelization or using GPUs and the clusters or cloud computing that is available there. So we need to integrate this solution, either data model, together with those that are provided by hardware capacity to make the computation efficient. And I believe that still there are a lot of room to make the computation efficient in terms of doing research in that area.
Okay, Babak, thank you very much for answering the last question. Unless the audience has a last question. If not, I would like to thank you and everybody in the audience for being present and being